All right, everybody. This is the last video in chapter 6 set of videos, which is on the geometric distribution. So the last part of 6.3 here. The geometric distribution, very similar to the binomial distribution that we talked about in the last video. But here we have one slight other difference. And so what is the geometric distribution? It's when we perform independent trials of the same chance process and record the number of trials needed to reach the first success. Okay, so this is a big difference between the binomial and the geometric. Is in the binomial we had a set number of trials and we were counting the number of successes we got out of those trials. But here we're looking at where we don't know the number of trials, right? We're going to keep doing it until we get our first try, until we get our first success. Okay, and so we use a different acronym for this. We use an acronym called let's see, BINS or BITS. Sorry, BINS is for the binomial, BITS is for geometric. Put it up here. So the B, again, same starting point. We start with the same with the binomial. You either have a success or failure. The independence part is still there. This is all the same. Okay. The part that changes in the T, which is we have trials needed until first success. So the T is like your trials with a question mark. We're trying to figure out the number of trials we need. And S is the probability of success remains constant. Okay, so everything stays the same except for the third letter here, which is the T. Before we had an N for a set number of trials. Here we have a T for trials needed until the first success. Okay. And so what are the possible values that you could take on? Well, first I'm going to denote y. I'm going to say let y equal the number of trials it takes to get one success out of some chance process. Okay, so I'm just going to define my variable. And if you think about, well, what could y be? Well, I mean, technically, y can be any number. So y can take on any value, integer value, I should say, right? So 0, 1, 2, 3, ... right? I mean, in theory, you could flip a coin a whole bunch of times, right? And it could take you, 10 million tries before you get your first head. Okay, so this can go on, as long as it needs to. And so, what's the parameter that we use? So before in the binomial, we had a parameter of n and p, where we had the number of trials and a probability. Here, we don't know the number of trials, so we just have one parameter, which is p, which is your probability. Okay, and so here we give you this monopoly situation, and we're looking at if you can roll a double, and the probability of rolling a double is 1/6. Okay, and you want to see how many rolls it takes to get to your first double. Okay, so explain why this is a geometric setting. Okay, the B, the binomial, you either get a double or you don't. So that's the B. I is independent. Yeah, if my first coin flip or my first roll of the dice isn't going to impact the second roll of the dice. Third one, the T, we're doing the number of trials until we get our first double. Okay, so that's exactly what a geometric is. And the probability of success remains the same at 1/6. Okay. And so if we're going to look at this problem, we said we want to define some things. We're going to say y equals the number of attempts it takes to roll a double once. And p is equal to 1/6. And then I want you to think about this. I want you to think about, find the probability it takes exactly to get one roll to get out of jail, right? And so if I'm rolling, so let's say I roll the dice the first time. So I'm going to say the probability that y equals 1. Well, what does that actually mean? Think about what this means. that means that the likelihood that you get a double is a 1/6, okay? And so if I only roll the dice once, that means I got 1/6 0 times. So this is just the 0 power, okay? That means I also had the likelihood of not getting a double, which is 5/6, and I got that one time, so that's 5/6 to the first. And then think about what it would be for probability that y equals 2. Okay, think about what that means, and think about in terms of success and failure, and how many times you got to get each one of those. Okay, so it's kind of an interesting thing. Kind of think about that, and you'll kind of get an equation that we'll talk about in class. So I'm going to leave those two blank. We'll kind of talk about those later on. Okay. So what do these things look like? There's a picture in your textbook, but these are heavily skewed right, and we have a mean of 1 over p. And so in your textbook, there's a good picture of these distributions. And if you think about it, why is the mean 1 over p? Well, if you roll a double, the likelihood of rolling a double is 1/6. You would expect that it takes 6 times in order to get one double, right? 6 times 1/6 is 1. So that's kind of where this mean comes from. This whole idea that, okay, if I roll it 6 times, I'm probably going to get one double. So 1 divided by 1/6 is 6, which is where that number comes from. But that's the end of the notes. It's a pretty short video. Again, we'll talk about some of these kind of finer details in class, but I just wanted to give you a brief introduction to this. As always, if you have questions, please let me know. But if not, have a great rest of your day.